3.3. Sometimes when we deal with our logs, they're not in base of 10. And when they're not in base of 10 and they're not a simple what exponent makes another number, like log base 2 of 32, we should know that it's going to be 5 because the exponent of 5 on the 2 gives me the 32. But when I come down here, I don't know what exponent on 4 is going to give me 30. So I need to be able to use what's called the change of base. And this little box here explains what that change of base is. But it basically is we put the log of the number over the log of the base. Once we do that log of the number over log of the base, it automatically defaults into a base of 10. So then it's just a matter of punching it in your calculator, log 30, make sure to close your parenthesis, divide log of 4, give me 4 decimal places, so 2.4534. So in this next one, log base 2 of x, I would say log base x over log base 2. I can't simplify this because I don't know what x represents, so I would leave it alone. In the next one, I'd have log 4 divide log 7. That I can punch in my calculator. Make sure again to use appropriate parentheses. 4 decimal places is okay for 0.7124. But this is just a matter of changing it so that you can put it into what we call calculator ready form. It's ready for the calculator once I have it in base 10. Since the logarithmic functions with base A is the inverse of the exponential function with base A, we have some properties that we can use. And these properties are called expanding and condensing. Here we have, we're expanding into something else. And it works for logs and with natural logs. It doesn't matter if that's log or ln. It makes zero difference. If I have something that's multiplied, I can expand it by putting addition between them. If I have something that is divided, I can expand them by subtracting. And you do it in the order you read it. So the numerator goes first, subtracted by the denominator. If I have an exponent, it gets to go out front. It becomes the coefficient of the log. And again, it doesn't matter ln or log. Something multiplied gets to be separated with addition. Something divided gets to be separated with subtraction. And whatever's an exponent moves out in front to be a coefficient. So here I have write the logarithm in terms of natural log of 2 and natural log of 3. So what I'd want to do is replace 6 with 2 and 3. Well, the only way 6 is 2 and 3 is if it's 2 times 3. Well, if it's 2 times 3, then I can separate them or expand it with addition. Here I have 2 divided by 27. Well, I already know what 2 is because it's given to me. So 27 I need to rewrite. Hopefully we should know that as 3 cubed. Because when I rewrite in terms of, it means I need to use those numbers. So if I have division, that's natural log of 2, subtract natural log of 3 cubed. But if I have an exponent, I get to move it out front. So natural log of 2 minus 3 natural log of 3. Because the exponents move in front of to become a coefficient. Here we get to use some of our rules. Log base 4 of 4. So if the base are the same, it leaves x. Here I have 4 of 64. Well, 64 is really 4 cubed. So I get to cancel those and say x is 3. Here we're going to verify that negative log to the 1/2 is really the log of 2. Well, negative means that there's a negative 1 out front. A negative 1 is a coefficient. So that's 1/2 to the negative 1. A negative exponent means I get to reciprocate or cross the line, change the sign. So the 1/2 becomes 2. And so the natural log of 2 is the natural log of 2. And that's how we verify. All right, here we have an example that we want to expand. It is some multiplication and some exponents. So because this is all multiplied, I don't need to write base of 10. 10 is implied. 5 multiplication log x cubed. Multiplication, so plus log of y. The way that we would clean this up is that we would take that 3 as an exponent and we would move it as a coefficient. So we would say log 5 plus 3 log of x plus log of y. The 3 is only attached to the x, so the 3 can only be the coefficient of the log x. It cannot go to the 5 in the y. Alright, natural log doesn't matter, ln or log. First thing we're going to do is that we should recognize that a square root means 1/2. We should be able to write that as an exponent. Now I have division. So division means that I get to separate with subtraction. And the way we're going to clean it up is that a fraction gets to move out as a coefficient. So 1/2 natural log of 3x minus 5 minus the natural log of 7. So that's expanding. Now we want to condense. So we have stuff that's addition, we have coefficients, and we want to change them back into multiplication, division, and exponents. So we're going to start with the coefficients. Coefficients become exponents. Coefficients become exponents. So I have log x to the 1/2 and log x plus 1 cubed. Now, the addition means I get to combine them into 1 log x to the 1/2 times x plus 1 cubed. Alright, so here we have a coefficient. We're going to first change that, so we get natural log x plus 2 squared. Now I have a subtraction, so 1 log, natural log. What I read first goes first. Subtraction means division, so x plus 2 squared over x. In part C, there is no coefficients. All it is subtraction. Log becomes 1 log, first one divided by the second one. So that's condensing back down to 1 log. Okay, this last one, you're going to need your calculator. And we're going to go through these steps of how to put it into your calculator here. They give you some data information. So what you first need to do is you need to put this data information into list 1 and list 2. And the way that we do that is we go to stat, we go to edit, and then we put in L1 and L2 data points. So stat and edit. In L1 and in L2, we're going to put these data points, and then we're going to do a sketch of them. So go ahead and do that. Okay, so under our stat and edit, you should have input your L1 and L2s in. Then it said to go to a graph. You want to make sure that your when you put in your L1 and your L2, that when you graph it, that you make your window according to your data. So probably 0 to 10 in the X values and 0 to 30 in the Y values, just so you can get a cleaner sketch of it, and we see that it does increase. Now it says, from the graph, it's not clear how to find the equation. So what we're going to do is we're going to take the natural log of each of the values. We're going to take the natural log of X, and we're going to take the natural log of Y. There's a very, very simple way to do this without having to, retype these numbers in. And that's to go to your L3 column and your L4 column. So under Stat and Edit, you're going to go to the top of L3. You're going to arrow up to L3. And you're going to type in the natural log of L1, because that's where your X values are. And then you're going to get these values that show up. Same thing with L4. You're going to go all the way to the top of L4, and you are going to type in ln of L2, because L2 is where your Y values are. All right, so by doing this, you automatically get these values that are typed into this. Now it says they appear, if I were to graph this, it would appear to be closer to a line. So what they want you to do is choose the 2 points here. These are the two that they're looking at you to do, and to find the actual slope. So you go with your y minus y and your x minus x, and you can do that on your home screen there. And you should get approximately 1.5 or 3/2. So we're going to come up with y equals 3/2 x, because that's our slope. And again, you can punch that in your calculator, 0.632 divided by 0.421, and you see that it comes out to be 1.5, which is 3/2. So now to use the calculator to come up with the linear regression model, we know y equals 1.5x. We know the natural log of y is 3/2 the natural log of x, because we took the natural log of both sides. So what we have here is we're going to do some algebraic part of this. This is my e. It's going to kick up the other side. So y equals e to the 3/2 natural log of x. Well, we know what e to the 3/2 is, because I have a calculator and I can punch that in, e to the 3/2. So that's really 4.48 to the natural log of x equals y. And I can come up with those equations. We're going to do a few more of these in class and with homeworks and with practices, but this will at least get you started on how to use your calculator, L1, L2s, how to take the natural log of something, how to find the slope. But like I said, we're going to do quite a few more of those to practice with them. But that will conclude 3.3.